Yes. And here, and then graded water, and then the 2 PCR glucose, and that's it. And then the kappa, we have the kappa. Just multiply that. I think for one sample we give you, right? Or 2.
I will see. I'm not sure if I need 5 for the positive control, you mean?
Oh yeah, but
You think I don't know how strong it is.
But we need like 5 with all of this master mix.
Yes, okay. Then we do that.
Yeah, or you can take all
Put on the UV light in the chamber where we're going to make the master mix. That's very important. So we make sure that there will be no DNA there, because where we mix the master mix, there should be DNA free. So, so that's what we're going to do now. 10 minutes, and now it starts. You see that?
This is UV light?
Yes, it is. So now it starts working. So we have to wait. But in the meantime, we're waiting for this. We can prepare the rest. So that's why we now start to find all the things that we need. The enzyme, the primers, and also our samples. And we have the tubes where we are supposed to put it. So this is what we're going to do now. Here. This is the primers. This is the enzyme. And this one is for the positive control. And here is the samples from yesterday, the DNA we have. From yesterday, the extraction. And this will be the positive control. That will show us if we have what we're looking for in these 2 samples. Because this one we know is positive when we use these 2 primers in the PCR. Okay. So what I'm going to do now is I'm going to find a tube to mix the PCR mix. And then we have to calculate a little bit, because this says for each and I want to show you how I normally do it. If you see this one here, for example, this is what we should have in one sample.
Okay.
And here I calculate how many samples I have, and I always add 1 extra. That's because of the pipetting, that I make sure that I will always have enough mix for all my samples. So if we start here, excuse me, we can write like, this is a 96 well plate, and this is the one that should go into the PCR machine. So here we put S1, and here we can put S2, and on the 3rd line we put positive control. Okay? And here I set 1 sample, and it should be DNA, should be 5 microliter, and water should be 6.5, and master mix and I mean forward should be 0.5, reverse 0.5, and enzyme 12.5. So now we have decided that we have total 3 samples, and we have to add 1 extra, so we have to times it with 4. So 5 times 4, that's 20. No, excuse me, because this one is 5
Yeah.
in all. So 6.5 times 4.
Okay. So
How much is that?
6.5.
Yeah, that's 26. 26 microliters. And here it will be 2 microliter, 2 microliter, and 12.5 times 4. That's, they say 50?
50.
Yeah, 50 microliter. So now we can have, this will be our master mix.
Okay.
And we will have it, put it have it in one tube first, and then we can put it in this afterwards and add the DNA into it at the end before we put it in the machine.
So suppose if we are doing reverse transcripted RT, then that also we put like this, that in there, or there is some other.
Yeah, but that will be another protocol. Yeah.
But the way is same.
The PCR is the same because it's a reading. You know, it's always reads. So maybe I can also tell you what the PCR actually do. If you have a total DNA, like we have now in our tubes, and you want to look at one particular part of the DNA, you use primers to do that.
Yeah.
And it's depending on what species you like to see, find in your samples, if it's a human DNA or whether it's a fungi or whether it's a bacteria.
Okay.
Yeah. Like in this case, we have for the bacteria. So then we have used primers that will locate a special sequence in DNA. So the primer we are using now will stick to this sequence and not to anything else. So what happens is in the PCR machine is that first it's open up the double-threaded DNA by heating, and then it will be annealing where the primer stick to the DNA and fasten, and then it read in the opposite directions because it's always read 3 prime, 5 prime.
5 to 3.
Yeah, 5 to 3. Always reading like this. And then you will have, and then it's the end. You know, and then you will have a new round, and it will open up also the thread you already made.
Okay.
So it's amplifying all the time in each cyclus in the PCR machine. So at the end, you will have a lot of copies of the same area you want to look at. Yeah. Yes. But that's not from our samples, it's from something that was here. You see?
Something like a cleaning process.
Yes, it is. It is to make sure that when we start in this chamber, there is no other DNA. Yeah. That will contaminate our samples later. Interfere with the PCR mix.
So
this is water. Yeah.
So we
So
are adding this one.
Yeah, so 26 microliter of this and 2 of each of this, and enzyme 50 microliter. But what we can do now in the meantime when we're waiting is actually to spin down the primers and also spin down. You can actually change this also. Okay. Yeah. So we can spin down the, just leave the water here.
I can carry?
Yeah, you can hold it. So what we're going to do, we can spin down the primers like this. I think this is enough. And this one I need balance for.
Yeah.
So
This is just for mixing.
Or
No, this is for spinning down what comes up to the lid.
okay.
Yeah, and on, you know, at the walls, so everything comes down at the bottom. Yeah. So, oh, this already. So yeah, and this one was borrowed, and I always like to put it back the way I found it. So I take this back and put this on top.
So this is for another tube.
This is for the very, very smaller tube. Actually, also you can have PCR in tubes instead of having them on the
Okay. Well,
yeah, yeah, plate. You can have it in tubes instead. This took some time, you know.
So why this takes time?
we have kept for 10 minutes.
It's 10 minutes.
Yeah, we have kept there 10 minutes.
Yeah, you can actually set it for how long you want.
Yeah, but why? Because it's just a light you put on. This is the stupid questions.
Why?
Yeah, why? Because normally you put on a light, it shines, and why you have to wait 10 minutes?
Yeah, the sterilizing.
Yeah, if you.
It's sterilizing. Oh, thank you.
Yeah. Oh, you didn't know.
No.
Oh.
This is the thing with when
Yes.
you are don't know anything about the lab.
And that is good for new beginners, really.
Yeah.
This is to make sure that the UV light will actually.
Now I get it. It kills the. Yeah.
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 It's degrading the DNA if it's there.
Yes. So if there's some DNA inside, then it will
Yeah.
kill it.
Yes.
Or
Yeah.
destroy it or what
Yeah,
you call
destroy
it.
it.
Yeah.
So when you start, you know that your PCR mix will not be contaminated
Yeah.
by some DNA from here.
But anyway, we never keep DNA inside, no?
No, but you can do like this.
Anyway,
you know, you
I'm-
can do like this. You can
Anyway,
do a
I'm
lot of
working in
things.
that
Yeah.
Cross contamination.
Yeah, you have a pling and it's ready.
Mm-hmm.
So now I'm gonna put on the light so I can see what I'm doing in here. I only put back up this one, so I'm sure that I should actually have this one in here, a new one, so I don't use the one that I have on my bench where the DNA was. So what I'm gonna do, I'm gonna take this one in, and I'm gonna put on my glasses.
Okay.
So first I start with the water, if you hand that to me, and it says 26 microliters.
So we are putting 26 there. 26.
Yeah. $26 of this. You can actually keep it. And then I will take the forward and reverse. And that should be 2 of each.
So this sequence we have to follow, is it? Like first water and then...
No.
Anything.
That doesn't matter because this is a mix.
Yeah.
So it should be. And then it's the enzyme, and that should be 50 microliters.
So this is that DNA polymerase that is there.
Yeah. And now I do a couple of times up and down so it's completely mixed for our PCR. And what I should do now is I should put master mix on top here so we don't switch it with anything else. Okay, and we finished here. We can go back to our bench and put it on the PCR plate. Yeah. No, like this. Okay. So,
So this was the PCR plate.
yeah. Or 96 wells plate is more correct to say. But this goes into the PCR machine. But you can have, this is a whole plate, but you can also have tubes that are linked together and actually pick how many you like. So it's different things that fits into the machine actually. So now I'm going to find a pipette for 20 microliters. You see, this is 20 because I have to add 20 microliters of this mix into this plate.
Okay.
And as I said, I made for 4, but I only have 3 samples.
Yeah.
But I always made 1 extra. So I actually stick it a little bit against the wall
We need to add DNA also
afterwards.
afterwards.
Yeah. And you press the whole amount out so you can see now it's totally empty.
Yeah.
There is some left, but that's because it's not that much samples. If I've been doing the whole rack here, it might be even much less. Because the pipettes are always, or not always, but very often not exactly accurately. That's why you have also to check the pipettes.
Oh.
Yeah.
Okay.
So here is 3 tubes. Can you see?
Yes.
Yeah. So now the next step is to actually spin down this to make sure that everything goes to the bottom before we add DNA. So I think I have to go to the other bench. Get it to the bottom.
And only supernatant we need. Is that so?
Yeah, it's not. It's a supernatant. It's this should be actually clean solutions. But of course, when you like I said, when you have extracted DNA, sometimes there will be something on the bottom.
Yeah.
So you actually, depending on what kit you use, so you always try to keep above this when you pipette it out.
So clean is better. Cleaner one is better always.
Oh yes, in the PCR. Otherwise, you won't have any product. you will mess up with it with primers. They won't be able to stick to the DNA. There will be like dirt from our samples will be like inhibitor.
Okay.
Yeah, the PCR to attach to the DNA. Like we have it here.
Yeah.
So we don't have like positive here, for instance, or S2 becomes here where S1 should be. That's very important.
Yeah.
Especially when you have a lot of different samples. Yeah. So now we should add 5 microliters of DNA. I think I will use this one. You see here, 5 microliters. And here I try to go, if you see, I go in the lining right up here. Carefully, not to the bottom. Okay. What was this? See here?
Yeah. What is it?
Yeah, it's 5 microliters. And what I also like to do, I like maybe to take it very carefully up and down a little bit, so you don't make too many bubbles. Because if you have bubbles in the well, you might not have any PCR product at the end.
Okay.
It disturbs the reaction, but I will show you, because we will also do a centrifuge before we put it in the machine.
Now you need S2.
S2.
What is this white thing? Yeah, in the pipette.
That's a filter. So you make sure that you don't contaminate what's in it. Yeah. From the top of here, of the
Okay.
pipette. Yeah. This is also a nice way of keeping your pipette, because it stabilizes your way of working. And of course, again, when you have a lot of samples, this is important. So now I go to the wall, it goes down, and I go straight into it and try to mix it a little bit.
Okay.
Just not much, but very carefully, so you don't have all these bubbles. So then it will be the positive control at the end. And you always look here. Where are you? I'm at A3. A, 1, 2, 3.
Yeah.
Yeah. Okay. So now the next step is to find cover for this plate. So we have to cover it, and I think it's over here. It's here because here there is no glue, but when you open it, this is. So what you do is you keep it above, you can see, so you get it exact down, because as you first have put it there, it's difficult to do otherwise.
Okay.
Because of the glue. So that's why you shouldn't have any folds just try to do it very simply. So what I usually also do when I've been doing this is that I take this one and carefully go like this. So I make sure that this tighten up. And I only do it here now because I only have it on my 4 first valves on the plate. Yeah. Then you know that this will be properly sealed. Yeah.
If we are using all the wells, then we have to do it for everyone.
Yeah. Then I do it. Then I do it more like this.
Borders.
Yeah.
Okay. Okay.
All the ways. Yeah. But don't do it too hard. Do it just softly, because if you do it too hard, it's difficult to open it again, because then it can splash.
Yes.
You know.
Yeah.
So yeah. So now the next step is to go in and centrifuge this plate before we put it in the machine. Yeah. Maybe I can keep it.
Centrifuge.
Yeah. For 1 minute, I have to, or maybe we can take 2 to make sure. And it's at 4 degrees, yeah. And speed is okay. And this is how fast it goes up and how fast it goes back down to 0. So this is what we're going to use now. And why we're going to use this is because if you see here, up to the light, you can see the bubbles there. There is a bubble, there is a bubble, and there. I mean, even if you are very good pipetting, you might got bubbles. And if I wouldn't get rid of this, I wouldn't have any PCR product. So what I'm going to do now is I'm going to use my finger like this, try to get them out carefully. Hopefully. You see, this is not so bad. It's these 2 here. So we're going to do it and see if this helps when we centrifuge. And on the opposite side, you have this balanced with an empty plate.
Yeah, so important with the balance.
Yes, always. So now we're gonna program it. I think we choose like 2 minutes, and it should be 1200. That's okay. And it says 4 degrees, doesn't matter. Usually they say room temperature, but that's no big deal actually, because it's so, I mean, 2 minutes is next to nothing.
So this is also in the protocol, right? 2 minutes?
No, 1 minute. It says 1 minute, 20 degrees. Yeah, and it's 1,000. But
we can change.
yeah, you can. When you have a little practice, you know that this doesn't matter if it's 200 more and 1 minute more and a lower temperature. Yeah. Hopefully now it's gone. So I'm gonna do that. Now I'm gonna do it for 1 more minute only. Okay, close it. And here I go to 1 minute. Okay, and I start it over again.
Focus on this. Doesn't focus. Okay. Let's see now if I can manage like here. Yeah, I got it.
Yeah.
I'll cut out something.
Now that we are here now, because if other people comes, they need to know who is running this machine.
So this is the PCR machine.
Yeah.
So such books should be there also.
Yes. So this is the book that you
No, it's on.
put the date and the time you're
Yes.
going to use it.
Today
and,
is the 7th, isn't it?
Yeah.
I don't know.
Yes.
Yeah.
7-2.
And it's 11:30. Okay. And
How long?
just put done.
How long does it take?
We will see.
Ah.
When we have put it in, it will say how long time that's left.
Ah, okay.
Yeah. So now it's just warming up so I can program it.
Sorry, it's 6-2.
I thought it was the 6th yesterday.
It's
I
a
don't
day,
know why.
World Environmental Day, 15.
You see system booting? Please stand by. I have my own program in here that I made a while ago. Some I'm using it. It's saved under my name. But of course you can make your own program, yeah? Or,
Can you just show
Yes.
how you have made that program?
no, that's a takes too long time. I won't do that right now, but you can see how it is, the program.
Okay.
So here I'm just have to look for my name. It's not there. I have to go back up. Okay, then I use Nassau. Maybe I put it there. No, here we go. I saw my name here. Here. It's me. Okay? And I gonna open it up. Here. And stick it in. And you will also, this will only fit one way. And you see here, this one should be on your upper right hand. Because here is you can see here is a cut in the corner.
Okay.
So if you put it like this, it won't fit. That's also important to know. So, you see here, goes in. We are closing it down. And I say play, start one. And now it's asking me, what is the volume? Is that correct? 25, yes. We have 20 with the master mix and we have 5 with the DNA. So that's okay.
25.
Yeah, so I say start run now.
Temperature will you keep there?
It's everything in the program. But you will see when the program comes up now.
Okay.
Because it will show on the screen. Yeah. See? Now it starts. You see now it's here. So it starts now to warm up to 95 degrees.
Okay.
And it will stay there for 3 minutes.
Uh-huh.
And then you will have still 30 seconds here with 95. And then it will fall to 58 degrees for 30 seconds. It will go back up to 72 degrees for 30 seconds. And this is, if you see this marking here, this is the cycluses. And I put this for 45 cycluses. So this will be repeated 45 times. And then you will go here for the same temperature for 5 minutes. And then this is the end. And then it will lower to 4 because you can actually keep it on 4 degrees for a long time. If you don't collect it at once it's finished, it can stay on 4. It's like in the refrigerator. Yeah. So now this will show here that we have now 1 hour and 40 minutes remaining time. So in 1 hour and 40 minutes this operation will be finished. Yeah.
So we are running for 45 seconds.
Yeah, 45 seconds. So this is what I say that you can make for yourself. What suits your samples? What are you looking for? What species do you look for? What you think is best for this and so on. All this has to do with experience and also what other people use. I mean, this is how you just have to figure out what is the best for exact my sample. Yeah. So you can change actually everything here.
So So here we are analyzing DNA or gene or what we are.
We are analyzing, as here we want to see if we have an exact sequence in the DNA. Because it's DNA all the wells, and we are putting primers into the well that we want to anneal to the DNA at certain places, because we know exactly where this should be stick to the DNA, and then it should read this particular sequence. So if we don't have any products and we have a positive control here, so we know that if the positive controls comes up on the gel that we are doing afterwards, we know that this has been successful. But if we don't have products from our samples, meaning that we probably don't have this certain sequence in our samples. Yeah.
Just do it. So why do you want to actually do it? That's the...
Well, like for instance, now we have saliva.
Yeah.
And we are wondering what type of, for instance, bacteria do we have contained in this saliva?
Aha.
Or do we have this special fungi in this saliva?
Yeah,
Then
so
we
you can
use-
test actually.
Then we use primers to see if we have fungi or bacteria in the saliva. This is an opportunity that we can look for.
And if there's fungi or bacteria in the saliva, then you can say that this patient, is it related to a diagnosis of the patient?
Well, it's interesting, and you can then take your research further, and maybe you can look for what type of fungi is it, or what type of bacteria is it. That's also possible to find out.
So yeah. Okay. So it has reached this.
Now it has started for the first cycle amount here. Then we don't use more agarose than needed, because everything that we use are expensive. So that's why it's important to just make sure that we have enough, but we don't need to make too much. Okay. So what I'm going to do here, this has 3 grams of agarose with 200 milliliter of this buffer. Okay. But I'm going to take the half of it. So I'm going to have 1.5 gram of agarose and 100 milliliter of this buffer.
And 5 microliter.
This is gel red. This is actually something you put into the agarose gel because this will highlight your products in the UV light later. If you have something, if you have a product.
Okay.
Yeah.
So we are going to see that one in the UV light?
Yeah, at the end. Okay. So now we're going to make this one.
Okay. Gel
1.5 and 100 ml with the buffer, and then we're going to put it in a little chamber so it can be cold. Yeah.
What did you put?
0.75 gram.
Okay, and
Of
what did
this.
So that's the...
Yeah.
What
This
is it called?
agarose gel. Agarose. Yeah. So we just put it here,
Rosa.
up in this one. Okay. And what I'm going to do, I'm going to leave this up here because it's there for everyone to make. So the next one, can you sit? 50 microliter here.
Okay.
Yeah, with the buffer. little extra for something is vaporing in this microwave, so I just have a little bit extra in it. So, this I'm going to use later when I'm mixing it with this gel red. So what I'm going to do now, try carefully to do like this. Boil. You can also boil it in a little bottle with a lid on top.
Okay.
Yeah, but make sure it's open, because when it's boiling, it's making vapor, so you will have a pressure.
Okay.
So it always should be a little bit open if you use that. I've used this now because this is just a test. But if you want to be quite sterile, you should actually have a little bottle with a lid on the top.
And we'll boil it where?
Hmm?
Where to boil?
Boil it here,
Microwave.
in the microwave.
Okay.
Yeah.
Ja.
Because we can open it, so it doesn't matter.
Nei. Ja.
Yeah.
Nå-
So I just follow what's happening in here. When it starts bubbling, I maybe take it out and I stir a little bit and put it back in.
Ja.
We have something up against the wall, so it's important to have it really warm. It should be blank actually before you
Before you finished.
yes. You see here, still you can see something up against the wall, so it should be warmer like this. So you make sure that you will have everything loose. But you can see now it's boiling in there. Oh. You see it's even boiling when I'm staring at it. So I think this is okay. So. Nice, clear solution.
Yeah.
Yeah. So we just keep it there, and I keep the gel red, and we make the gel in this. I found this. There should be another plate here for. I'll just see if it's here. Take sure. Put it right here. Fasten it like this, so the gel won't go out on the side here. Okay? So now I'm gonna have this this red gel. This doesn't go further, go only to 2. So I need one for 2.5. 2.5 with this one. This doesn't like light, that's why it's kept in this silver paper. So this is gel red. Can you please hold it for me?
Yeah.
Because I want to keep it up in this one. Okay. Now we can switch. You can hold this. Don't burn yourself.
So 2.5, right?
you keep this for me. And now what I'm going to do this very carefully. Not shake it, but just turn it a little bit up and down. Because if you shake it, you get bubbles. And if you get bubbles, you don't get a nice
Gel.
no, smooth and nice. So the products can be a little bit, you know, bumpy. Yeah. Now it looks nice. Has been loosened. It's quite a little bit pink. I don't know if you see it.
Pink at the bottom, right?
Yeah, it's pink. I can see it's pink.
Yeah, yeah.
Yeah. So, take this out here. Carefully at the bottom. Because I want to take out all the bubbles. And there is not many bubbles here, but there is a few, and we're just going to take it out after we've done this. Okay. So first I'm going to use a stick. That's my way of doing it. Of course you can, maybe you have other ways of doing this. Take it into the sides here. So make sure you take it away. This wasn't easy though. Here we go. And then I put the comb into the gel, because this comb is the one that make the wells in the gel. So now when we are putting the PCR product to the gel, we're going to put it into these small tiny wells that we have made in the gel.
Okay. So that they can come down.
Yeah. So now we can leave this and wait till it's cold. It's ready, because here we have to mix the PCR product from S1, S2 and positive control with 3 microliters of loading buffer. And the loading buffer function as to keep the samples down in the agarose gel.
Okay.
So it won't flow up.
Okay.
So it sticks to the to the DNA, to the product, and keep it down, so it can slightly walk through the gel instead of coming up from the wells. Yeah. Just before I'm loading it. But we can release it from this. See here how nicely it drops. So it can stay here till we start. But I will wash this in the meantime and put it back. Here.
This is the same buffer that we use for this.
Yeah, in the gel. Yeah.
Okay.
Maybe this. We shouldn't have too much. It will go over. So we will see when we have the gel there how we have to, if we have to need some more. So, I think today we're going to use this one. I wonder if this, no, it's not on. Yeah.
What is the function of the buffer here? What we do, like why we have kept buffer there?
Why we have the buffer here? Now it's just to have the Jones. You see, because of the electrical movement, this will move from minus to plus.
Okay.
So that's why we have to have this correct electrodes, and also I think you should stop here because I have to discuss a little.
Oh yeah.
I wonder if this is. I think this is okay. is the loading buffer we're going to use. And the loading buffer will keep our sample down in the valve, in the gel. Otherwise, it will be us ejecting it to it and it will just flow up.
Okay.
But with this, half sticks to it, keep it down, make it heavy.
Okay.
Yeah. Make this ready. 3 microliter of loading buffer to the bottom. Okay. It's finished, it's 000. So what we can do actually is to stop it. And what does it say? Are you sure? Yes, I'm sure. And now, stopping the run. So now the time is 13. And I said okay. So now when this is stopped, we can open it up and we can turn off the machine. It's quite warm on top. Okay. And I can actually go home. You see here? And I can stop it. Are you sure you want the cover off? Yes. 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 So I take out 5 microliters of each sample and up to these tubes where the loading buffer is. So actually it's totally of 8 microliter that will be put on the gel. Yeah, in each well. So I think I'll maybe use this one. So when we open this now, we have to be careful so it don't splash around and so not this go into this one.
Yeah.
Because then you will have contamination.
Yeah.
That's why this is an important step to do careful. One by one. I like to open them one by one. But this is also, of course, different how people like to do or not. This is 5 microliters.
Mixing also?
I do that. This is just a bad habit or a good habit. I don't know.
So we are transferring 5 microliter.
Yeah. 5 of each sample. So now I take number 2. You can see how this would be kind of difficult when you have a lot of samples.
Yeah.
So you make sure you don't get anything else down to the wells. Okay. This you can leave for further analysis, whatever you like to do with it. This is here is just to see that we have the product in it. So this can be used for many different things.
Okay.
Yeah. Sequencing, deep sequencing. You can look for specific exons and mutations, and you can look for what type of bacteria, what type of fungi is in it. You see. So you can do, as long as you have a product, this will only tell us whether there is something in here or not. So this is not to go further with, but this one is to go further with further analysis. Yeah. I think that I just have to ask for this ladder, and then we have to start the gel.
Now we have it.
This is a DNA ladder, and it's with 100 base pair. That means that this will show different molecular weights in the gel. So it's very nice to run this at the same time as we do our samples, because it will tell us somehow how big our product is, what kind of molecular weight it's sort under. You see, there is many different of them, and that is of course depending on what you are looking for.
Okay.
Yeah. So for our purpose, it's the best to have the ladder with 100 base pair, not this big one, because this takes maybe shows us with the molecular weight much more than we expect to have in our products. So that's why this will give a better separation on a lower weight. Yeah. So now I think we can just go in and put things on the gel.
So that is called
DNA ladder.
DNA ladder. This one?
Yes. What I usually do, now this is cold, it looks quite nice. I usually place it in the buffer before I take out the comb. Okay, I see that I should have been using maybe a little less. You see it goes over, but we just have to change it afterwards. Oh, anyway, it's enough buffer. So, now we can take out this one, the combs, and the buffer of course will go into the valve. Just do this carefully so you don't break it. You see? Now there is also buffer into the hole in the gel. So, here we go. Yeah. What I usually do also, this is only buffer and we can change it afterwards. I use a colored underlayer, so it's easier to find the holes in the gel. And then it's also easier to this will be a mess. This was kind of wet. So now I put a red underlayer, so it's easier to see where the wells are in the gel, and then it's easier to know where to put the pipette tip into it. That's also a tip. So first I'm going to start with the DNA ladder at the end, and then that should be 2 or 3 How much was it? I think it was 3. Can you check?
380. Then I'll do this half of that.
3 microliter of this leather, DNA leather. So we need a little lightning here. This red one wasn't the best actually. It was nice. You see how nice it is?
You can.
I think I managed to zoom all the way.
Now we start with the samples.
Should be very difficult to put like this, right?
Yeah, this
Because
is
of
also.
buffer?
Yeah, it's a training. It's a training matter. Now we need 8 microliters
Of sample.
of sample and loading buffer. The loading buffer came because of keeping the DNA in the wall. We have to put power into the system. So we stick this cables into a power source. And what's important is that DNA will walk from positive against, from negative against the positive, because DNA is a negative molecule. So that's also that's why important to have this from minus till plus here, and also to have the right cables in the right position in the source. So now I'm gonna look at how much should we put it on. Should put it. I like to put it like very, very slowly in the beginning, because if you put it like on 40, you will have the sample to actually come down or stick together in the valve before it starts to walk. So I always put it in on 40 just for like 5 or 10 minutes, and then you can speed up afterwards. So now it says 40. And I should set run. Yeah, and what you can see here, if you look into this, is that now you have a lot of bubble coming up here at this end, meaning that this has started to to run. So now the DNA will probably stick a little bit together in the walls. And then after a while, start to move above and out of the wall and against the positive pole. Okay. Do you come to here and see how you can use?
Yeah, you can take this one also.
So now I take some minutes here, and then after one while I have to rush it. Maybe more than I actually like to do also, because I have to go. I have to go to the dentist, so we should be finished here. I do it for 40 in 5 minutes, I think, and then after a while I'm going to just speed it up. Now I think I will speed it up. So I just press this button and I put it up to at least maybe 80, I think at 85. Okay? Then it will go faster. You will see more bubbles there when you speed it up. You see now it looks, no, you can see this is more activity. Now we stop the gel and see if we can have nice pictures of it and see if it's
But are you sure you stopped? It says still 100 there.
no, but it stopped. You can see it here.
Oh yeah.
Yeah.
Because it's 100 volt, so actually
Yeah.
if you
Yeah.
touch the connectors, you might.
But you can just stop it like that, and then you can turn it off afterwards. So. Okay. Usually I just do this a little bit. And leave it like this. So I'm gonna take it out.
Yep. It's very blurry, so.
Usually I do it like this because there always comes a lot of liquid out of it.
This?
Yeah, what is this?
And we leave it in here and see if we can have a nice picture. This is a photographing gem.
Okay. Okay.
Actually, here is a ladder, and here is sample number 1. This is sample number 2, and this is sample number 3.
Yeah, that is
Yeah.
a positive control.
Yeah, this is the positive control, but it looks like this should be the positive control as well. So it's you can see how many similar band it is.
Yeah.
Yeah. But it's also strange. Why is the difference between this one and this one?
S1 and S2. Is
Yeah.
it?
Yeah. We should ask Dana about that. Because she was the one
after caffeine.
who took who gave us the samples.
Yeah.
And I don't know what she put into it. Maybe she